as I was listening to the panel earlier today and to Jim Rogers and Jeff Sturbis speak, the complexity, the problems, and the challenges of our grid and the internet and the utility net are really so similar. And I'm hopeful that Paul will be able to highlight some of that point. Paul Marcoux, thank you.
At Cisco, we're committed to green operations. We have, as you can see, we have an impact on how we operate our business. Our architecture is providing us solutions to our customers. We do not believe that essentially giving answers that are strictly Cisco-centric is going to be the answer. Again, it has to be a collaborative effort. Our employees, I'm relatively new with the company, and I can report to you that one of my very first tasks was to essentially meet with all the senior executives, meet with the second tier, and all the way down to the technicians level. I have literally had hundreds of meetings. Essentially, our networks operate and run the internet. Your technology for energy solutions will operate on that internet. If you can take a look at just using this one slide, you can see it's about 1.1 billion people. Within the next 3 years, that number will almost double. The amount of connections that are going into Asia, Europe, are just phenomenal. So consequently, they need to understand how we deliver a green solution. We do it through not only our architectures, but as you know, we do it through our data centers. This graph that you see operating in front of you was actually developed on a mini supercomputer. It's called computational fluid dynamics. That's the heat generated by a typical data center. As you know, every watt of energy that goes into a data center is converted into heat. That heat eventually has to be piped, pumped, or moved outside to be cooled. So as you can see, where's all this energy go? It's really simple. It's conversion losses, we have lighting, we have cooling. When you understand the relationship between your infrastructure and your cooling, it's almost a 1 to a 1.1 relationship. So in other words, when you bring in equipment into your IT operations and you take a look at it from an electrical perspective, that electrical perspective has to also have a corresponding cooling perspective. So we talk about each watt consumed in the infrastructure has an ability to generate an additional 1.1 to 2.5 times the load. We talk about our power supplies. Power supplies are the end results of where all this technology resides. It is our goal in our design right now to not only improve what we call the ASICs, and for some of people who are not familiar with that term, but it's basically the circuit boards that are within our product lines to maximize their energy efficiency. We also want to increase and develop an ability with other companies that people, not only Cisco, can monitor and manage our products with their existing networks. So as you see, although Cisco in itself networks in a data center operation is really a very small element, everything in the data center or technological area reports through our networks. As you can see, most of the energy right now is being consumed by the servers and the storage areas. Huge strides are being made right now in reducing those requirements. Not only is Cisco very involved in our technological innovations, but we're also very much involved in our physical networks to compare them against our human networks. let me tell you an idea that we understand in Cisco. Greening isn't a technological problem. It's a social problem. That's why everyone here understands it. As you can see, this is our area for connected urban development. This is an investment of approximately $15 billion. We've launched this investment with many other areas, and as you can see, it consumes cities. And the reason we're calling it connected urban development is because we are connecting various cities. These cities will not only operate, the trial cities will not only operate on a unique process for managing and controlling the actual distribution and using of like traffic signals, roadway control, but more than that, it also has the ability to allow workplaces to be essentially moved from congested areas to non-congested areas. Another area that we have is connected real estate. Again, this is even a finer element of the urban development, which is basically a transportation. This one here is really a communications and workplace. The convergent networks, we believe, will be essentially, you won't be going in the future to your office. Your office may be a telecommuting location that you will be going to. We have studies that show we can reduce the operating expense by 30% by utilizing this process. And we have also shown that it develops a 40% reduction in electrical usage. Changing the way our products work. As I said before, it is very important that we design products that are for a sustainable future. In other words, they do not contain hazardous materials. They are operating at the most efficiently designed possible solutions that we can engineer into them. And that they have intelligence. This intelligence is what is going to drive Web 2.0. It's going to allow not only Cisco, but again, many other companies to be able to access and control this type of electrical consumption. Not only has the ability to change the way we work, but it also has the ability to change the way we use energy across our company. Cisco actually has basically two goals. One, it's internally focused, and two, it's an externally focused organization. The control of energy internally is through installation of water-saving, electrical saving devices. To give you some idea, we use essentially 80 million gallons of water less, 8 million gallons of water less in the San Francisco area today than we did several years ago. We are an 80 megawatt site of electricity consumption. Therefore, we are a major player in energy conservation. A lot of our purchases, 15% of them, are green purchases right now. So we not only explained that water usage, energy usage, but really, most importantly, it's monitoring and management. And that concludes this brief statement. Thank you.